Hello students, in this particular class we will be talking about the evaluation of ecosystem services. And this week entirely we are dedicating for the ecosystem services. We remember that what we discussed in the last two classes. Services and the concept evolution, we have tried to understand the flow as well as we tried to understand how ecosystem services are linked with the functions and processes. In the last lecture, we discussed the types of ecosystem services, provisioning, regulating, cultural, and supporting services. And I hope you remember the very nice example of the Central Park, New York City. Today, what we are going to discuss? We will be discussing ecosystem service evaluation, what exactly we evaluate. And then we will be discussing the categories of these methods and one particular category we will pick up for today's discussion, that is biophysical ecosystem service valuation models. InVEST model and ARIES model, these two will be discussing today with the case example from San Pedro River, Arizona. So let us first start with the evaluation. Ecosystem services valuation is the process of identifying, quantifying, and where possible, monetizing the contributions of ecosystem functions to human welfare. It is linked with the ecological processes with economic and social systems so that the benefits of ecosystems can be incorporated into decision making. Ecosystem service assessment refers to the quantitative or qualitative estimation of ecosystem services through biophysical indicators, economic valuation, and sociocultural appraisal. And all are aiming at integrating ecological knowledge into management and policy. Why it is relevant? Researchers, they translate ecological functions such as carbon sequestration, nutrient retention, or water purification into benefits that can be compared with other components of the economy. And what decision makers can do? They can evaluate trade-offs, design compensation mechanisms, and justify conservation investments within a cost-benefit framework, which suits our social system as well. So when we go for this evaluation, largely we will find there will be three different steps. Measurement of the ecological functions and service supply, and valuation in biophysical, monetary or non-monetary terms, and integration of all these values into planning or policy instruments. So these are the three main steps we find in the ecosystem service evaluation. What exactly is getting evaluated? We evaluate the supply, ecological capacity, the demand side, the human beings who will take it, and the value which is being given to this output from the ecology and as well as need for the human beings. That's the benefit and the significance of it. So if you follow this image, you just see the supply side is here and the demand side is there. It's a socio-economic side, it's a biophysical domain, and we are having the ecosystem services, output of these ecological systems and input to the socio-economic system. So that's the way the supply and demand are getting balanced, and continuously we are appreciating the value of these ecosystem services. So let us again go for these three important terms one by one. Supply, which represents the biophysical potential of ecosystems to provide goods and services determined by the land cover, biodiversity, and ecological processes such as nutrient cycling or hydrological regulation. Demand side, which captures where and how people require or use ecosystem benefits. Spatially distributed they are among the beneficiaries. Demand is influenced by population density, accessibility, and socio-economic preferences. So, if it's a two different societies, they may have two different type of demands on the same ecological resource. That is very important to understand. So the value is actually very much contextual. It emerges where supply meets demands and reflect the contribution of ecosystem service to human welfare, expressed in biophysical, economic, or socio-cultural terms. This corresponds to the total economic value framework. We'll be discussing this in details, which includes use, non-use, option, altruistic, and bequest values. There will be other methods as well, but we'll be discussing all these values. So, what we are saying, again, we are coming back to the discussion of the supply and the demand side. Supply side, we talked about biophysical value, which is coming from the ecosystem services, and the demand side is the socio-cultural value and the economic value. So, demand side, they determine these two values and which is being used by the beneficiaries. But at the same time, is very important. This is very important to take note of the trade-offs. It's not only benefits. Whenever we talk about benefits, we have to think about also the trade-offs. And all these things brought together, integrated into the discussion, actually makes the decision makers taking their decisions how to integrate it. So, ecosystem service evaluation methods can be grouped according to the type of information used to describe and value services, each addressing a different dimension of the relationship between the nature and the society. Three complementary categories. By now, we have understood that biophysical, economic, and socio-cultural one. Each one of them are addressing different dimensions of the relationship between nature and the society, that is ecosystem and the human well-being, and together they form the basis of integrated ecosystem service assessment. Let us go one by one. Biophysical assessment, characterization of ecosystem structures and functions and relation to ecosystem service provisioning. You just see, it is having a very direct and important relation with the regulating service. It is contributing to cultural as well as provisioning service, but not as directly like regulating one. Similarly, we can look at the social assessment, which applies to sociological service, interviews, focus group discussions. These are the methods it is utilizing, and directly it contributes to the cultural service significantly, and also to the provisioning one as well as to the regulating one, but comparatively of the lesser gradients. Economic assessment, there are several methods like market value analysis, avoided damage caused, contingent valuation methods, and directly it is being utilized for the provisioning services as well as cultural and regulating services as well. So, that is the main structure which we discussed for the evaluation methods. Again, we will repeat it once again category wise. Biophysical or ecological valuation, how much of a service is produced by that ecosystem? That's the question. Outputs we get into the quantitative units like tons of carbon per year. What are the methods or tools we use? Field and indicator method. GIS mapping, InVEST, ARIES, costing nature. These are the methods and tools. In the economic one, the monetary valuation, the question is, what is the service's economic worth to society? That's the key question it answers. And its outputs comes into the monetary value, rupee. The methods and tools utilized are the market price, avoided cost, travel cost, hedonic prices, contingency valuation methods, T framework, and we will be discussing them one by one. So don't get afraid about these new methods, but be aware about them. The third category which we discussed, that is the socio-cultural or participatory valuation. The question being answered is, how do people perceive and prioritize ecosystem benefits. How we do it? We put scores, rankings, spatial hotspot we identify. Qualitative index is the most common way of evaluating them. The methods what we use here: survey, participatory GIS, Q method, solves. Solves we will be discussing in detail. And also, as ecosystem is a complex thing, is not a very simple thing, any one of those categories cannot capture actually the ecosystem service value by fully. So integrated methods are also very common, and the question it is actually answering is how to combine ecological, economic and social information for decisions. So here multi-criteria index, scenario map, cost benefit ratio, these are the type of outputs. How we got them? InVEST, TEEB, ARIES, multi-criteria decision, natural capital accounting. These are the methods or tools utilized for this particular type of integrated evaluation methods. So now what we will be doing today and tomorrow in our next lecture, that is, we will be discussing these evaluation methods briefly as well as broadly. Let's see how we can discuss it. First one today we have picked up, that's a biophysical or the ecological valuation. And for that there are several different type of models, methods are available. InVEST, integrated valuation of ecosystem services and trade-offs. This will be discussed today. ARIES, artificial intelligence for ecosystem services. This will also be discussed. Costing nature, Envision or NSIM, Estimap, EcoServe GIS. These are some of the other important methods which you can learn as you will be getting opportunity. So first we'll be starting with the InVEST, the integrated valuation of ecosystem services and trade-offs. Who developed it? Natural Capital Project. Do you remember I mentioned about Dr. Gretchen Daly? Stanford University, WWF, the Nature Conservancy, University of Minnesota. It's a project of many different stakeholders. It was launched first time in 2008 and continuously getting updated. Its scope has been extended over 20 ecosystem service models, covering terrestrial, freshwater, marine, and urban context. And it has been used in 185 plus countries as well as 600 plus scientific publications are citing this model. So it's a very important and popular model for this ecosystem service evaluation. Its purpose is to quantify, map and monetize ecosystem services to inform environmental and economic decisions. What approach it takes? It uses the spatially explicit biophysical economic modeling to link land use land cover to ecosystem service, supply and value. Supply value we have discussed just now, supply, demand and value. So it is doing that. The outputs that comes as maps, biophysical metrics like tons of sediment retained, carbon sequestered, and economic valuation summaries like rupees per year. Supporting scenario analysis is also possible for restoration, development, or conservation. Types of ecosystem service modeled using this particular method is water yield and quality, carbon storage and sequestration, sediment retention, pollination services, habitat quality and biodiversity, urban cooling, and nutrient cycling and storm protection, and a number of additional services. What are the input data? We will be now discussing the methodology of this InVEST. Very quickly, in short, let us understand how it works. LULC maps climate data like precipitation, temperature, then the soil and topography, ecosystem property coefficients like sediment retention efficiency, socioeconomic data where economic valuation is needed. That is very important, as I was telling, how society takes it. So these are the input data. Model selection and parameterization. You may choose relevant modules like water yield, carbon storage. You can calibrate parameters using local data and literature. How to run this model? It's a GIS based software process which processes the spatial data and parameter inputs. It calculates supply, demand, and beneficiary locations, applies the ecological production functions. So, not only supply, demand, value, also the beneficiary locations. That is very interesting to take a note. Outputs, already I have discussed the outputs, maps of ecosystem service spatial distribution and supply versus the demand. Biophysical results like tons per year or cubic meter in per year, economic valuation wherever relevant, and scenario comparison summaries for decision support. That's another very important output it generates. Let us go for an example. Marine Invest model has been used in this particular case, and we will see that this is the literature. You can study this one. For this marine invest, input data came from the terrestrial sites as well as the socio-economic side, and the scenario has been created. That has come as an input. And what has been looked at? The process looked at the water quality as well as the habitat risk. And you can see so many important parameters have been identified like carbon, wave energy, coastal protection, recreation, fishery, aquaculture, and aesthetic qualities. Just look at the water quality and the linkage with the aquaculture. So, water quality is actually influencing the aquaculture, as well as aquaculture is also influencing the water quality. So, that type of relation is getting modeled, and that process is actually being utilized for getting this valuation. So, what are the ecosystem services the model outputs brings? Carbon sequestered, energy captured, avoided area, visitation rate, landed biomass, harvested biomass. And the valuation has been done for the carbon sequestration, net present value of captured wave energy, value of avoided damage. We will be discussing that avoided damage. Expenditure due to recreation activities, net present value of finfish and shellfish, net present value of the catch. So that's the way this marine invest models are helping people who are into the business as well as the decision makers, that how to really take care of this ecosystem service optimally. Number two, which we'll be discussing, that is slightly different but mostly similar. It is artificial intelligence for ecosystem services. It was developed by Basque Center for Climate Change BC3, led by Villa and international collaborators. It was initially launched in 2009, actively updated. It is a web based open source toolkit integrating semantic web, AI, and spatial model. So, it is having the technical part stronger, quantifies, maps, and analyzes the supply, flow, demand, and beneficiaries of ecosystem services, emphasizing how benefits move from nature to people. That's the purpose of ARIES. And it uses AI, Bayesian network, and semantic modeling to select and combine ecological and socio-economic models automatically based on input data. So you can easily understand both this, the previous one as well as this ARIES. They are actually taking advantage of already existing models, and they are utilizing it, they are integrating it as and when it is required and relevant. What outputs it brings? It generates detailed maps and quantitative reports of ecosystem provision, flows, demands, and final beneficiaries. Handles uncertainty, and this is a very specific character for which Aries is gaining confidence among the decision makers, because you can see where it can go wrong. So it also handles the uncertainty and identifies actual pathways, not just the potential supply. What are the scale in which it can work? It can work for the city scale, region scale, or the country level. That's a very strong strength, I will say. Supports high resolution local analysis to global assessments. So it's a local to global. Types of ecosystem services it can model: provisioning, regulating, cultural, supporting. Again, there is a series of services which it can model. Now, again, let us look at the ARIES methodology. User sets goals and defines areas, selects types of ecosystem services, beneficiaries, policies, and scenarios of interest. Then the data gathering starts. Once the data has been collected through AI or all different type of means like social, economic data, remote sense, global national databases, user also can upload, all these things are done, then harmonization of the data is very important, bringing them on a common acceptable platform. Next stage is the dynamic model building. Automatically builds spatial Bayesian network models for ecosystem service provision, flow from ecosystem to people, and use, incorporating uncertainty and context specific data. Flow analysis it does, traces actual pathways of ecosystem service flow like routing floodwaters, mapping pollination travel, visibility for cultural services from source to beneficiary. And always it factor in real world barriers and depletion. For that only it can give us the information on the uncertainty. The scenario testing is the next step it follows, which allows analysis and comparison of different land use management, climate, or policy scenario. So, any strategic decision, we can test that scenario. Output and visualization. This is another strong strength, that is the visualization. Provides rich spatial outputs like maps, charts, quantifying where our ecosystem service originates, their movement, and who receives the benefits. Results are in the form of spatial maps of our ecosystem supply, flow, use, and final beneficiaries. Quantitative indicators like cubic meter of flood water mitigated, something like that. Scenario comparison, pre-post urbanization, climate adaptation strategy taken and before case, after and before case. Uncertainty visualization. This is one interface. It looks like that when you work with ARIES, where you choose your user defined data set and then you keep on working on it. Now we'll be discussing one particular case which is actually a comparative evaluation model, comparative case for two different evaluation models which we have discussed just now for the San Pedro River. So, this evaluation, the particular study, what it has done, it has picked up the area, that is the San Pedro River watershed. It is in Arizona. Quantitatively, it compared InVEST as well as the ARIES ecosystem service models for carbon sequestration, water supply, and view sheds. What is view sheds? From any location, whatever different points of interest you can see, that is the view sheds. Under realistic land use scenarios like urban growth and the mesquite management. Stakeholders is a multi-stakeholder program. Input data, consistent land cover layers, precipitation, dry and the wet year, two different data sets have been utilized. Soils, elevation, population, view quality, and the management scenario inputs were integrated. So, this is that San Pedro River watershed. But you have to note that it is actually, that river is actually coming to the Mexico. This is the international border. And this is that area which has been studied. And it is also having not only the Bureau of Land Management's their area, but it is also beyond that area, the watershed area. So both the conservation area plus the watershed area. Both models, that InVEST as well as the ARIES, consistently predict losses in carbon stock, increased water yield, that is less filtration is happening, so more runoff is getting generated under the urbanization, and declining viewshed quality, though they provide outputs in different units and spatial details. Very recently, I was going through a very interesting study which has come from the Australian universities. Have you gone through that? I don't know. That carbon stock. Previously, the forests were giving us only a very strong positive carbon sequestered scenario. Now, as the climate is changing, the trees in the forest are actually dying very soon, sooner than the expected lifetime. So, what is happening? That carbon is coming back to the system easily. So, now the scientists in that particular forest chunk, they have studied it for long period and they have identified this particular problem. So, we don't know whether in future other forests also are going to really behave like that. So, this carbon stock becomes a very, very dynamic state again in that case, that even the forests are not being able to conserve the carbon properly. So, that also probably will be a future urban challenge. Spatial explicitness we see in this study is the InVEST, which is better for the scenario comparison, easier to set up for multiple services, and provides more aggregate numbers. Whereas ARIES provided something else, mapped service flows, who benefits where, and quantifies uncertainty. Thus, the Bayesian network does. The magnitude wise, both the models are giving the direction very similar, and relative magnitudes are also acceptable range. Under open urban development, both show about a 20% annual loss in carbon sequestration, 7 to 12% increase in water yield, and a trebling 3 times the number in the visible blight features or areas. So that interesting spots are decreasing tremendously. Setup time for InVEST, it was 275 hours for 4 models, whereas ARIES, it used 5 models and 800 hours, including the data and model development. The data requirement both require robust land cover and climate data. ARIES needs more detail for flow and users, Bayesian network. Usability, InVEST is faster, more user friendly. ARIES provides advanced spatial flow and uncertainty details, but is more technical to set up. So, this is the way this particular study looks like. This upper part is using the InVEST and the lower part is using the ARIES. So, this one is for the carbon sequestration, which I have discussed right now, which is showing the similar but not exactly same numbers. In the same way, we have to read this one. Again, the InVEST is on top and the ARIES is at the bottom, and water yield is the parameter which has been studied in this particular slide, has been presented in this particular slide. You can see here the data came for the dry year as well as the wet year. So, InVEST used that 2002 and 2007 data, and they could see that water yield is increasing not only in the wet year but also in the dry year. ARIES has shown that infiltration is decreasing. Next is the viewshed baseline and the urban growth. So the first one is the baseline, and then there are two scenario. One is constrained one is the open one. This is the very similar three scenarios continuously, consistently has been studied over carbon sequestration, water yield, as well as the viewshed. And again, you can see the InVEST result as well as the ARIES result, and you can see that it has really increased like anything. That's the blight spots. So we can summarize the study like this: the quantitatively both are in agreement for direction of change and order of magnitude values in carbon and water services. Differences mostly from the model definitions, input handling and output aggregation. Uncertainty: InVEST is giving us the deterministic results unless user manually varies the parameters across runs, whereas ARIES explicitly quantifies and maps the uncertainty, coefficient of variation, Bayesian model ranges, per ecosystem service, and thus it is aiding risk-based decisions. Stronger local data and iterative calibration or computer time and test that will improve the accuracy and the policy relevance. So that is the learning from this particular exercise. So today what we discussed: ecosystem service, evaluation, why we do, how to do the categories, and one particular category, that is the biophysical one, that has been discussed in detail. InVEST and ARIES, we have also seen a very interesting comparative study. Not only these two models, what they do individually, we have tried to see the application of these two models for the same case. So that was a great learning. These are the references. Thank you.